So you met me before. I don't have to introduce myself, hopefully. I don't think there are any non-SSD, SSP students doing this module, but if there are, then my name is Dermot O'Connor, and I'll be presenting all aspects of this module. So I think we can just go straight into it, really. Let me see. Okay. Can I just get confirmation from somebody that you can see my screen?
Yeah,
Uh, yeah, okay, good. Right. So I've shared this URL with you, and again, for those of you that sat in my Agile Software Practice module last year, you'll be familiar with this kind of website layout that I use. So I'm just maybe I should start here, really, giving you a very brief overview. And the first thing we're actually going to look at, oddly enough, maybe is we're going to look at a language called TypeScript, which some of you may actually already have done some programming in TypeScript. But I'm going to give a quick, um, I won't call it a review because you may not have seen it before, but a quick kind of crash course, I guess, in TypeScript, because that's the language that we will be using throughout this module. It may seem like an odd choice, but I could have picked any number of languages like Python or Go or C Sharp or Java. But given that most of ye, if not all of ye, have got a lot of kind of JavaScript experience, then the transition to TypeScript will be pretty straightforward. But before we do that, let's have a quick overview of this module. So I'm just going to go through these slides here. It'll only take a few moments. Okay, so the very first bullet point here, I literally took straight out of the module specification um, for this module. And while the specification was written, I guess it could be actually maybe 5, 6, 7 years ago now, really. It's still accurate enough, even though the material that I'm going to be covering is a bit more modern than would be expressed in the module specification. But this sentence here is still relevant, I suppose. So what it's saying is that the objective of the module is that students would be able to comprehend the architecture of modern distributed. And by distributed, really today we implicitly kind of mean cloud-based. Distributed systems as a title has been around for decades, really, way, way, way back, long before cloud was ever an aspect of software developers' kind of tool set. And distributed system simply means that the functionality of an application is not resident on one server. And we tend to be more focused on server side functionality now rather than client side. But distributed, the notion of distributed systems, like I said, has been there for a number of decades. And it simply meant in the early years, distributing your functionality across individual server machines. And I guess it still means that today, but the only difference is we don't own the servers. That is, of course, if we are availing of cloud-based services. So today, and for this module, when we talk about when I talk about distributed systems, I'm talking about systems or applications that are deployed to the cloud. And they are still distributed, though. The different parts of the functionality are not all resident on within one operating system process on one machine. They're distributed across certainly across a number of operating system processes, and more than likely as well across individual uh, servers, be they virtual servers or hardware servers. We are dealing in the virtual world really, so it'll be virtualized servers. So understanding the architecture, which is kind of a high level understanding of how the functionality is distributed. Now that might suggest to you that this is a more a theoretical module, and I can assure you it is not. It'll be very much practical based. And that's reflected really in the second part of the sentence here. So as well as understanding or comprehending the architecture, I'm also interested in students being able to develop and deploy distributed applications with a particular emphasis or maybe a stronger emphasis on the deployment side. Obviously, we'll be developing as well, but I'm not overly concerned about the nature of the functionality. What we are probably slightly more interested in is the deployment of functionality across your virtual servers that are running in the cloud. So there's a big emphasis on deployment in this module. And, like I said there a moment ago, we're not too concerned about developing very sophisticated functionality. So we're only interested in what I'm calling a constrained set of requirements, constrained set of functional requirements or user requirements. It's, as I said, it's not the actual functionality, but it's the deployment of that functionality and deploying it based on maybe alternative architecture styles. And down here, then I'm elaborating a little bit on that kind of overall sentence. I'm trying to break it down a little bit. So some of the topics that we will come across are infrastructure as code, and that is targeting specifically this whole deployment area. So we won't be using manual deployment steps. We'll actually automate the whole deployment of our distributed application. And that involves using kind of tools which are generically classified as infrastructure as code tools. So that'll be interesting, I think, for you. Here I'm mentioning something called serverless, which is a very current architecture style. So we need to, first of all, explain what we mean by serverless, and then we'll actually practice deploying fairly straightforward functionality to a serverless architecture. Uh, Whenever you're talking about distributed applications, you're always interested or you need to be conscious of scalability. Scalability here kind of refers to the ability of your deployed application to handle spikes in traffic. So if there is certainly a spike in demand for your application, then can your application scale up and respond to that spike in demand? And equally, when the demand uh, decreases, you'd like your application scalability to also kind of wind down. And scalability really means we need to allocate more um, compute resources to our distributed application so that it can deal with the spikes in demand for it. We're not going to go into scalability in any kind of heavy way, but at various stages, I will reference the scalability issues depending on what particular topic we're looking at. I'll skip over microservices for a second. The other dominant architecture today is what's referred to as an event-driven architecture. So again, we need to understand what does that mean and how do we achieve an event-driven architecture for an application that's deployed to the cloud. Now, as usual in lecture one, these are all terms which don't mean a whole lot to us, but certainly, hopefully by the end of the module, all of these terms will make sense to you, and you will be able to not only comprehend them, but also practice them, I suppose, which is what we're talking about in the second part of that sentence here. I've already alluded to the fact that we're going to be using TypeScript as our language, both for here, the infrastructure as code side. So we're going to be writing TypeScript code to facilitate deploying functionality to the cloud and maybe deploying it to a serverless architecture and or to an event-driven architecture. Um, uh, the actual functionality will also be implemented in TypeScript. So it's kind of a nice uh, single language that covers everything for us. As I said, I could have picked any number of languages, but I've decided to go with TypeScript. Pre uh, Prerequisites. There's nothing really new here for you, and I'm kind of assuming that everybody in the audience now is a former student of the Agile software practice. But just for the sake of it, everybody needs to have an AWS account, their own personal AWS account. You need to have the AWS CLI installed. I don't know, did we use the AWS CLI in the Agile software? I think we may have used it in the Agile software practice module last semester. If not, this is the URL that you should go to install the CLI on your own desktop or your own laptop computer. You need to have Node installed. You need to use VS Code. Well, you don't have to use VS Code, but I use it throughout this module. You need to have Git, of course. You need to have a GitHub account, and you need to have knowledge of JavaScript. So again, there's nothing particularly new there. I'm just showing you on the right here the status of some of these tools on my machine at the moment. So it looks like I have this particular version of the CLI, the AWS CLI. As long as it's version 2 dot anything, that will be fine. A version 1.x is too old. And currently I'm using Node version 22, but it doesn't have to be. Something slightly older would suffice as well. You also need to be kind of familiar with the AWS Management Console, which again is something we played with a little bit in the Agile module last year, but we'll be using it a lot in this module as well, mainly as a way of confirming that um, our cloud resources have been set up properly by the infrastructure as code that we've written. What's going on here? Okay, just some general kind of stuff. Uh, Students always want to know the assessment structure. So it's a 100% CA module. And again, the breakdown here is very similar to the way I did the Agile module. So there'll be about maybe three labs that you will be submitting to me. Worth 10%, two assignments collectively worth 50%, and there'll be a lab-based exam during week 13 worth 40%. So that's very similar to the way we worked on the Agile module. You already have this URL, and as before, I only use Moodle for assignment submissions. If you don't see this module when you log into Moodle, try self-enrolling using this enrollment key here. That may or may not work for you. I'm not certain whether I'm allowed to enable students to self-enroll, but anyway, we won't be using, well, we will actually, you will be submitting something to me in about 2 weeks' time. So check on Moodle if you can see this module. And if not, try this. And if that doesn't work, just get in touch with me and I'll enroll you. This is just a screenshot from the website from last year, just to give you an idea of kind of the main topics that we're going to cover. So I'm going to start off by looking at TypeScript again. Then we're going to look at a tool called the Cloud Development Kit. And that's the tool that will allow us to write or express our infrastructure as code. And we will be using this Cloud Development Kit right throughout the module. So I'm giving you an intro to it here, and then we'll be leveraging it throughout the semester. Then I'll talk about the whole serverless architecture style, and we will deploy some functionality to a serverless environment on AWS. It'll all be over on the AWS platform. Skip over this for now because I'm not sure whether I covered this or not. And the last card here is all about the event-driven architecture. So we cover that at the back end of this module. And from an assignment point of view, my thinking right now is that we'll have one assignment on serverless, one assignment on event-driven architecture. Okay, just as an overview, are there any issues that you want to ask me about? Is there any questions that come to mind at this early stage? No? Okay, let's go back to the actual website. And if we come into this card here, I'm going to give you, as I said, a quick kind of crash course on the TypeScript language. There's an accompanying lab. The labs are very similar in style to the labs from the Agile Software Practice module for last semester. So you need to work your way through these various sections. Depending on how far I get in today's lecture, will dictate how far you can get through in this lab. Although you may be adventurous and you may decide to try and complete all of the lab. We'll see. We'll see how far we get in the lecture. So I'm now going to go into these slides here and talk my way through them. Now, as I work my way through these slides, I will be referencing code excerpts to demonstrate the various aspects of the language, and you can download the code yourselves if you just clone this GitHub repo. You can do that maybe at the beginning when you start working on the lab, and you can use it as a reference. So just some kind of interesting but not very useful background information on the language itself, TypeScript. It was designed by an individual who works with Microsoft, this guy here. I'm not brave enough to try and pronounce his surname. I don't know how you pronounce that, but he certainly has a fairly checkered history in the whole area of software development because he's the person who designed the C# language, Turbo Pascal. Okay, and he has now added TypeScript to his list of languages that he's designed, so that's pretty impressive. TypeScript itself is, as you probably know, it's very much linked with JavaScript, and you also know that JavaScript is very much linked with ECMAScript. Does anybody know what is the link between ECMAScript and JavaScript? No. ECMAScript is the specification for the JavaScript language. And the ECMAScript specification, there is roughly a new release of the ECMAScript specification every year, going back as far as around 1995, I think. So there's been various upgrades, if you like, to the ECMAScript specification, which is why there has been various upgrades to the JavaScript language over the years. And specifically, this guy that designed the TypeScript language, he specifically used the version 4 of the ECMAScript language and version 6 of the, sorry, not of the ECMAScript language, of the ECMAScript specification, and version 6 of the ECMAScript specification. ECMAScript 6 was a fairly significant um, uh, part of the ECMAScript history because that's when we got classes and a number of other features introduced into the JavaScript language. So that's just by the way. So it's very much grounded. TypeScript is very much grounded in uh, the history of JavaScript itself. Uh, Technically, kind of JavaScript we say is a superset. Sorry, TypeScript is a superset of JavaScript. That kind of means that really every JavaScript file is can be just renamed to .ts and it's a TypeScript file. Now, JavaScript, if you just do that, your TypeScript is probably not very well written, but essentially you can do that. Uh, the thing that you need to remember about TypeScript is, and a lot of people don't appreciate this, TypeScript is just a compile time language. There is no runtime environment for TypeScript. TypeScript has to be compiled, and the output of that compilation is plain old JavaScript. The JavaScript then you can execute using either Node or it can be executed within the browser. So you need to remember that TypeScript is a compile time language and what it compiles to is JavaScript. Put another way, JavaScript is the runtime uh, form of the TypeScript language, which is the point that I'm making here. And all I've got down here in these two bullet points are just comments made by some people that would be very well known in the web development world. For example, there's this person called Bernard Eich. Does anybody know who Bernard Eich is? Bernard Eich is the person that designed the JavaScript language. Yeah. So his comment was that what he really liked about TypeScript was the fact that it supports what's referred to as type inferencing. And I'll explain what type inferencing is as I work my way through these slides. So he became a fan of TypeScript, even though really TypeScript now is sort of a competitor of JavaScript. There are very, very few, in fact, probably none, new web-based projects being written in JavaScript. They're all being written in TypeScript today. So it has essentially kind of pushed JavaScript to the side as a development language. Of course, we know from up here that JavaScript is still very much relevant in the kind of runtime world. Okay, let's move on to some hard facts though. Although maybe just before that, what I'm showing you here is you see every year the GitHub platform publishes a report every single year. Excuse me. And one of the parts of that report is where it tells us what are the most popular languages on the GitHub platform. And so we can see the history here of the roughly the top 10 languages on the GitHub platform over the years, going way back to 2014. And you can see that TypeScript has risen to position number 3, which is pretty impressive because all of the languages that are mentioned here are much older than TypeScript. TypeScript really, what did I say in the previous slide? TypeScript was created around 2012. But all of these other languages predate that. So it has really risen to, it has taken a fairly meteoric rise to position number 3. Just by the way, not at all relevant to this module, but this is the very first year that Python actually has risen to position number 1 in this kind of uh, top 10 of languages. That's mainly because Python is the dominant language for AI implementations. But so from our point of view, anyway, TypeScript, we can kind of conclude from this that TypeScript is really a very important language for any graduate to have some knowledge of. Now, TypeScript files themselves, by convention, their extension is .ts, but there are also what are called declaration files, .t, .ts files. Declaration files are similar to header files in languages like C and C++, if you've done any programming in those languages. So in these declaration files, that's where we place the definition of the various data types that we have defined for our application. The .ts files is where we put the actual kind of source code, the executable code. And these declaration files, as I said, they provide type definitions. We'll use them a little bit. You can put your type definitions into your TS files as well. There's no problem with that. But just from a kind of separation of concerns point of view, certainly if you're developing a large application, TypeScript application, you would put all of your type declarations into these declaration files and your source code into your TS files. But as I said, you can actually put declarations into a TS file as well. And you probably see me doing that every now and again. They're analogous to header files, as I said. What they're actually very useful for as well is they are they're added to third-party JavaScript libraries. You see, there's an awful lot of third-party JavaScript packages out there that we would like to use in our TypeScript projects. But in order to allow us to do that, we need to somehow create TypeScript declarations for our JavaScript code. So what a lot of third-party JavaScript library developers have done is added these declaration files to their JavaScript packages so that we can actually import them and use them within our TypeScript projects. And you will see evidence of that throughout this module. Now, any language has what are called its primitive data types, and the primitive data types of TypeScript are the ones that you would get for pretty much any language. And also and I'm just listing them here, and you can kind of determine from looking at the list that some of them are actually taken directly from the JavaScript language. So anyway, there's a numbers type, number type, a Boolean type, a string type. They're all primitive types built into the language. TypeScript also has the null type, and it has the undefined type, and it's the undefined type that's taken directly from JavaScript. Can anybody tell me when might a variable have the undefined value associated with it. When you declare a variable, uh, you may or may not want to initialize that variable when you declare it. If you don't initialize it, what value does a variable have in JavaScript now? So the answer is an uninitialized variable in JavaScript is assigned the undefined value. It's a kind of curiously, it's probably badly named, and it goes way, way back to the origins of the JavaScript language. But it simply means that a variable that has the undefined value has not been assigned any value yet. It's not so much that it's not defined, it's just it hasn't been assigned an initial value. And it's actually the source of many, many problems in JavaScript projects when essentially when a JavaScript project crashes. In many cases, the crash can be tracked back to the fact that a particular variable is uninitialized, its value is undefined. The other case when undefined arises is if you've got an object structure in JavaScript and you try and reference a property of that object that does not exist. In that case, you also get the undefined value. So in TypeScript, we couldn't ignore this undefined value from JavaScript. So it has been carried forward basically into the TypeScript language. So these are all the primitive types in TypeScript. And then everything else in TypeScript, just as in JavaScript, everything else is of type object. So classes and modules and interfaces, they're all classified as object types in TypeScript. There's also this kind of odd one, but in fact it's pretty important. There's what's called the any type. So a variable's type could be the any type, which simply means it could have any value. By the way, one of the main differences between JavaScript and TypeScript, and you probably know this already, is that JavaScript is a dynamically typed language. That's how we would classify it. JavaScript is a dynamically typed language. What does that mean? It means when you declare a variable in JavaScript, you can assign it any type of value that you want to. So in one line, you might assign it a number. The next line, you might assign it a string. On the next line, you might assign it a Boolean. And on the next line, you might assign it an actual object. And from the JavaScript runtime environment perspective, it doesn't care that you're doing that. Clearly, it would be bad programming, but the language allows it, which is why we describe JavaScript as a dynamically typed language. TypeScript, on the other hand, is a statically typed language. That means that when you declare a variable and you assign it a particular type of value, be it a primitive or some particular type of object, you can never change the type of value that you assign to that variable afterwards. You can change the value, but the type of that value cannot be changed. The compiler will complain about that. Now, having said all of that, though, if you've got a variable in TypeScript and its type is the any type, then you're essentially going back to JavaScript. You're saying that this variable can be assigned any type of value. You're allowed to do that in TypeScript, but it is considered very bad programming. But it's kind of in there as an extreme kind of fallback. Now, on the next slide, I just found this image somewhere on the internet, and I thought it's kind of useful, even though we don't have to uh, examine it very closely. But what it's showing us is the type uh, hierarchy that's built into the JavaScript language itself. Just bear with me for 1 second, sorry now. Okay, there's just something popping up on my screen. So just bear with me for a second. Okay, this is type the type system uh, hierarchy that's built into the TypeScript language. And you can see at the very top of the hierarchy, well, almost at the very top, there is one above it here, but we can ignore that one. At the very top is the AnyType. And all of the primitives, the Boolean number string, they're all inherit from the AnyType. And over here we have object, and object has subordinates typed arrays and etc. etc. Okay, so the AnyType is kind of important at one level, even though it's something that we should always try to avoid. And of course, over here is our friend, the undefined type, which also is subordinate to the AnyType and the void type as well. You'll see examples of void in a while. I wouldn't worry too much about this diagram itself. Just have an awareness of the fact that there is this type called the AnyType, which is at the top of the TypeScript's type hierarchy, built-in type hierarchy. Of course, what we will be doing a lot is defining our own custom types, and they will kind of emanate from here. Okay, custom types are subordinate to the object type. Okay, let's not get bogged down maybe in this too much. Go back to the previous one. Okay, also mentioning here the fact that TypeScript supports typed arrays, which is really nice. That's something you don't have in JavaScript, and it can be a pain point, really. Now, in terms of the language syntax itself, the TypeScript language syntax, the very first thing that you're going to come across is what are called type annotations. And here's an example of what I mean by type annotation. So I'm declaring a variable here using the let keyword, which is straight from JavaScript. The variable is called me, and this part here is what we refer to as a type annotation. And this is where we are stating what type this variable is. And so it looks like it's going to be of the primitive type string, which means now that we can only ever assign strings to this variable. And that's what we're doing over here. So the compiler is going to be happy with that. So in terms of the language anyway, this here is what's called a type annotation. So it's this postfix syntax as it's termed. For typed arrays, we use this subscript kind of notation to indicate that a variable is an array. So this here, we're declaring a variable called mynums, and it looks like it's going to be an array of primitive number types. And that's consistent with what's being assigned to it over here. Now we can change this array, of course, but at all times, this variable can only be referring to an array of numbers, which could be an empty array as well, but uh, can also apply annotations to functions, and we'll see more of that a little bit later on. But to give you a preview of it, you can see down here, I'm declaring a function, and the way you interpret all of this is this function takes two parameters, and the first parameter is of numeric type. The second parameter also happens to be primitive numeric type. And the way you interpret this bit over here is this is telling us what the return type of the function is. And if you look at the actual body of the function, which is trivial, it is actually returning the summation of A and B. And of course, that expression is going to be a numeric expression, or the result of this execution of this expression is going to be a number, which is why over here we're saying that the return type of this function is number. But for now, anyway, all we're saying is that this type annotation syntax uh, can be used in function signatures as well. Let's pop over to VS Code. So what I'm showing you here now is uh, the TypeScript project that you can download from GitHub that I mentioned there a while back. And so if we go into the source folder, and I've just broken it up into the various topics that I want to cover or aspects of the TypeScript language that I want to cover um, with G. So if we go into the basics folder, and here we've got a TypeScript file. Let's open that up. And we've just got some simple examples of a string, another example of a variable whose type is Boolean, whose type is number, sorry, and that's fine. Now, if I've commented out this line here, but if I uncomment it, then we get a kind of a warning here, and yeah, well, sorry, it's because we've got the kind of squiggly line underneath here. That's telling us that there is an error, a compiler error. The compiler is actually always working in the background as you're typing your code, and it's informing you of errors, TypeScript errors in your code. If you want to get the detail of the error, then you just need to look at the problems tab down here, and it will explain what the error is. And it's fairly straightforward. In this case, it's telling us that a type string is not assignable to a type number. And you can see here, I've declared this variable as being of type number. And here I'm trying to assign a string to it. And TypeScript compiler doesn't allow us to do that. In JavaScript, that's legal. Um, but again, it's probably not good programming if you've got a variable where on one place you assign it numeric value and somewhere else in your code you're assigning it a string. You're better off having two separate variables for that scenario. But as I said, we're dealing with TypeScript, and TypeScript just uh, doesn't allow you, sorry, to mix the types, the value types that you assign to a variable. So let's comment that out again to clean up our code. And everything else is fairly straightforward. We've got some console logs, nothing interesting there. We've got a Boolean variable here, that's okay. And it's lowercase, true and false. And if I uncomment this line, it doesn't make sense to try and add something to a Boolean variable, whereas you can do that in TypeScript. Sorry, keep mixing them up. You can do that in JavaScript. It's an odd thing to do, but the JavaScript runtime environment will execute that and produce some sort of result. But again, we're getting the warning here from the TypeScript compiler. And if we look at the message down here, you cannot use that operator, I guess, cannot be used on a Boolean type, is what it's telling us. So we'll uncomment that. Keep it happy. Now, as well as the primitive types that are built into the language, there are some other types that are added in as well, which are kind of useful. And all I'm doing is illustrating one of them here. There's the regular expression built-in type, and we were familiar with regular expressions from somewhere else in your computer science studies. So I'm just declaring a variable here of type regular expression. I'm assigning it a regular expression over here. Essentially, the regular expression is trying to look for year patterns in a string, like 19 something or 20 something. And I'm then just using that regular expression to test some strings that I have here. So the string does have a year in it, and I'm proving that by using my regular expression variable to evaluate whether it finds the pattern or not. And I'm doing something similar down here. Moving on, just to typed arrays. Here I've got an array of numbers. I think this is what I showed you on the slides. Let me just pull that down a little bit and commented out some stuff. Oh yeah, all I'm showing you here is there's actually two syntaxes that you can use for declaring an array. There's this syntax, which is really the one that you would use most often, but you can also use this syntax here. It's in this case, I'm declaring an array of strings. This kind of angle bracket and close angle bracket, that's referred to as generics in TypeScript, and I'll talk more detail about generics later on, either today or in the next lecture. And let's see. Now, if I just uncomment this here, so before I uncomment, I've got this array of numbers, and we know about the push operation for arrays that's taken straight from JavaScript, but I'm trying to push a string onto my array of numbers. Now, that should not be allowed, and if I uncomment that line, then again, I'm getting an error. And if we look at the error down here, argument of type string is not assignable to parameter of type number. So again, the compiler is telling us straight away before we ever run our code, and in fact, we won't be able to run this code because we have to compile it first into JavaScript, but the compiler won't allow it. Whereas in JavaScript, you can have mixed data types within an array. It's probably not good programming, but it's allowed from the language's point of view. So that's kind of further evidence of this static type nature of TypeScript. It's not allowing us to write that line of code. And okay, that's as far as we need to go with that. Of course, this is just a piece of script and it's got some console logs. So we'd like maybe when we're playing around with the language, we'd like to be able to run this code. Now, you could compile it first and then run the output of the compilation, but you can actually compile it and run it in one command. So let me show you how to do that. Now, of course, you'll see on the left here that this is really essentially it's a node project because I've got a package.json, the package.json um, includes the actual TypeScript language itself, it brings in the TypeScript language. This TS node is it's a package that contains a utility that will allow us to run our TypeScript code. Even though I said at the beginning of the lecture, TypeScript is a compile time language, not a runtime language, but this actually does allow me to run a TypeScript file. And so let's just do that. So if you get a terminal session, and the command is npx ts node, and then just point it at the actual file. So in my case, it's src in the 00 folder. Now the file name there is index.ts, but if we leave that out, then it will go looking for a file called index.ts. So I don't need to be explicit about it. And if I hit return, then what you're getting here are the outputs from the various console logs in my script, and you can check that later yourselves. Now, strictly speaking, what we're doing here is what TS Node does is it takes the TypeScript file, it compiles it into JavaScript, and then it runs that JavaScript on the Node platform. Does that all in one go. You don't see a physical evidence of the JavaScript. It's only stored in memory, not stored on the file system. Let's supposing we did actually want to see the JavaScript equivalent of our TypeScript, then what we can do in that case is we can compile our TypeScript using a utility called TSC. And do I need to give it the file name? I'll give it the file name anyway. Now, if you look up here, there's now a file called index.js, and that is the JavaScript equivalent of my TypeScript. And if I just open it up, even though you never really need to do that. So this is the plain old JavaScript. It's even got very old uh, keywords being used. It's kind of pre 2015 JavaScript, I guess you'd say, because it's using var rather than let or const. But that is the JavaScript equivalent of my TypeScript. And if I just leave it open and flick between the two, so what we often say is that any evidence of type related syntax disappears when you look at the JavaScript equivalent. So for here, for example, here's some type syntax, but when I look at the JavaScript, and here's kind of my string, where is it, my string here? There's no postfix syntax appearing here at all because that's not valid JavaScript. So this is plain old JavaScript, which is actually executed. And I can run this JavaScript now just using the node command as you would have before. And let's just do that by just going node. That's the same output that we got when we ran our TypeScript file through TS Node. Okay, so I've proven to you, if you like, that. What have I proven? That TypeScript does. Okay, I think I was muted accidentally. Can I check now if anybody can hear me? Okay, so you can see my screen now, isn't that right?
Yeah.
Great. Okay, I'll just push on to here, I think. Okay, uh, TypeScript has support for classes, but really it's taken directly from JavaScript support for classes. And I'm not going to talk about classes TE because you're very familiar with the concept of a class from other languages. So TypeScript has all the normal kind of support for inheritance and public and private properties and all of that stuff. And you can see some sample TypeScript class syntax there on the right. So I'm not going to talk through that. It's fairly straightforward. And let me just see if I can collapse something here. Sorry, no. Okay, to here. It also has support for interfaces. And again, like classes, you're very familiar with the concept of an interface from other languages, probably from Java. And you see examples of the TypeScript interface syntax. So equally, I'm not going to talk through that or demonstrate it because uh, it's kind of old hat as far as you're concerned. Okay, something that's uh, I suppose it's specific to TypeScript, maybe not be unique, but anyway, it's something called interface data types. It's unfortunate they used the word interface here as well, but what interface data types are, as I'm saying here, is they allow you to declare the shape of an object. By shape, we mean what properties is the object allowed to have, and what values, what type of values can those properties have. Okay, and so here's a simple example. This is a declaration of an interface data type for an object, and I've decided to call my type for the object person. So person here now is actually a custom type that I have defined for myself, and it's a custom type for an object structure. And the object I'm saying can only have two properties called first or last, and in this case, they both happen to be of type string. Here then, I'm actually declaring an object of that type. So it's that postfix syntax that we're using here, but we're actually specifying a custom type that we've defined ourselves. So the me object, the me variable, sorry, will have to point at an object where that object only has these two properties. And that's what we're getting here. So the compiler is going to be happy with that. Yeah. Um, let's have a look at that in our source code. So are we still in the same file? I think we are actually. Yeah, so here's the what I showed you on the on the PowerPoint slide. I've got a person type, interface data type, and I'm actually putting this is an example now of a type declaration that I was talking about earlier on, and I'm putting it into a source code, which you're allowed to do, but in a large application, you would try to put all of your type declarations into a declaration file. And you can see if I expand this one here, I've just brought in a declaration file here by way of illustration, but we don't need that for now. So here's a person anyway. And here I'm declaring an instance of person. And again, from a kind of compiler point of view, let's just see. If you take this line here, now you know in JavaScript, you can dynamically add properties to an object and remove properties from an object. But you cannot do that in TypeScript in many cases. So for example, if I uncomment this line here, where I'm trying to add an address property to the me object, again, the compiler is going to complain. And if we look at the complaint, it's saying that property address uh, does not exist on type person, and that's true. I haven't included it in my type declaration up here. So we're not allowed to do that in TypeScript, but we are in JavaScript. Uh, so let's clean up that. And just got some more examples going on then down here. So I've declared a CAO student type for myself with these properties. You can see one of the properties is actually an array of strings. So this interface data type syntax is extremely flexible. I've got an instance of CAO student here. Just again, another by way of example, I've got a semester result interface data type with these properties, and on it goes. And I've got a student exam profile. Okay. Anything interesting there? Well, you can see here that I'm using one of my other interface data types within the declaration of this interface data type. So these things here don't have to be primitives. They can be custom types as well. And eventually then I've got some actual objects. So this is an object here that's of type student exam profile. In other words, it should match this structure here. And if you follow it through, it is because each of these lines here is an instance of student result, and student result is defined up here. Yeah. So we can kind of we can define our custom types and we can nest them inside fairly complex objects if we need to. So lots of examples there of the use of the interface data type. Okay, so that's new from a syntax point of view. The next aspect of the language is what are called type aliases. And type aliases, I'm saying here, allow us to create new names for types. Now, this type alias syntax is it's extremely flexible, and you'll see as I work my way through these slides and the source code, lots of ways that we can use type aliases. The first and simplest way of using it is this example down here. You see, type aliases and interface data types, they actually overlap. There are two ways of declaring the same thing. I'm not sure. I've tried to read up on it, but I'm not sure why the designer of TypeScript uh, decided on that. But anyway, it's there and we have to live with it. Because if you look at this example down here, so I'm using the keyword type at the beginning of my type declaration. So the fact that I'm using the keyword type here, then I would say that what I've got here is a type alias declaration. But in fact, the type alias, what I'm declaring is effectively an object structure or an object shape. And that's the language I used when I was talking about interface data types. I said interface data types allow us to declare the shape for objects in our application. And this is doing the exact same. And there is no difference between this syntax for declaring the shape of a point object in this case and the syntax that we were using over here. They both do the same thing. There are slight differences in the syntax that you have to be aware of. Like there's no equals sign here, whereas there is an equals sign here, but that's just a pure syntax, right? But in terms of their effect, this has the exact same effect as an interface data type declaration. And you can mix and match the two, and one is not better than the other. However, type aliases allow you to do other things that you cannot do with interface data types. So for example, what you can do is declare what's called a union type. Here's an example of a union type. So I'm declaring a type, I'm giving it the name alphanumeric. By the way, I should really have capitalized the A there. It's conventional to capitalize your type declarations, whether you're using type aliases or interface data types. So anyway, I'm declaring a type, a custom type called alphanumeric, and I'm saying an alphanumeric variable could be a string or a number. So we interpret this as the or symbol. And so by way of example, I'm declaring here a variable called num. I'm saying its type is alphanumeric and I'm assigning it a numeric value. So from the compiler's point of view, it's happy with that line of code. This underlining here is not it's not the VS Code telling us about a compiler error. It's actually where VS Code VS Code uses this to inform us that you've declared the variable, but you haven't used it. Yeah. And we don't like unused variables in any language. Okay. So don't interpret this to be this is a compilation error. It's not. This is a perfectly legal and valid line of code based on the type alias that I've declared up here. I'm declaring another variable called str. It's also of type alphanumeric, but in this case, I'm assigning it a string. And syntactically, that's also acceptable because I've said up here that alphanumeric could be this or this. And there are cases when you will have variables and it's the value that you assign to it could be one of two different types, or maybe even more than two. They don't always have to be primitives. They could be custom types as well. So it's very flexible. Another use case for type aliases is what are called literal types. So here again, I'm actually using the type alias syntax. So I am declaring a type here. I'm not declaring a variable. That's something that you have to get familiar with from the language point of view, the difference between types and variables. This is a type. This is a variable. If I go back to the previous screen, this is a type. This is a variable. A variable is something that you assign a value to. I'm assigning this value. A type is something that declares a type. But this is kind of falling in between two stools, really. But again, it has some use cases. So I'm declaring a type called, in this case, pet category, and I'm saying a pet category variable can only have these specific values, one of these values, either cat or the string dog or the string goldfish. Here I'm declaring a variable. Its type is pet category, and I'm assigning it dog. And from the compiler's point of view, that's acceptable because of what I've set up here. Yeah. So as I said, there are use cases for both union types and type literals. I'll come back to those two things actually again later on. We'll revisit them. Let me just check, is there anything in the source code? Oh yeah, we've got some stuff on type aliases here. So I've got a course type. Now, again, I could have used the interface syntax here. In other words, I could have went interface. Get rid of the equals, and it has the exact same effect. Yeah, but I'll just put it back to what it was. Okay, I've got a course type, and these are the properties of a course. I've got an academic entity type, and I'm saying an academic entity could be a course or it could be a CAO student. And we defined CAO student earlier in this script, you remember. Okay, so that's fine. Academic entity is another custom type of mine. I've then got a variable. Uh, I've got a variable called entity. Its type is academic entity, which means it could be a course structure or a CAO student structure. And it looks like from just from examining it. Sorry, what am I doing? Oh, sorry, no, sorry, beg your pardon. Oh yeah, no, sorry. I'm declaring a variable here. Its type is academic entity, and I'm assigning it student X. And student X, did I declare that earlier on? Yeah, there's student X there of type CAO student. So that's fine. I've assigned a CAO student to an instance of academic entity. So syntactically, that's fine. And all I'm doing here is just, I'm just showing you an example of a function, let's say, where I'm passing it an academic entity. We don't really know what the function does. It's not important. Now, because I'm passing in an academic entity into this function, more than likely in the function, what it needs to do is determine, well, is it a CAO student or is it a course? Because that's probably going to change part of its processing. And the way we would do that is by means of just a simple if statement. So if we take this if statement here, what essentially it's doing is it's checking to see, does this parameter that was passed into me, does it contain a property called code? Okay. And you'll see here that course does have a property called code, but a CEO student does not have a property called code. So effectively what this if statement is determining is the parameter that was passed into me, the argument that was passed into me, is it a CEO student or is it a course? And that would determine what kind of processing it's doing. And then I'm invoking my function with a student in one case and a course in another case. So that's type aliases, um, which is a syntax that allows us to define our own custom types. Back to my slides. Type inferencing. Uh, type inferencing is this idea that the compiler will infer the type of a variable based on the value that's assigned to that variable. And the brilliant thing about type inferencing is that it allows us in many cases to not have to use the postfix syntax. Now, what do I mean by that? If I go back to VS Code and go right to the top of this, pick the simplest example possible. So here I'm using the postfix syntax to declare the type for this variable. But if I get rid of that, the compiler is clever enough to work out, well, the type of this variable is string because you've assigned it a string. So the compiler will infer the type for this variable for me. I don't have to be explicit about it. When you have a variable and there is no explicit declaration of its type, you can always check in VS Code as to what type it is. I mean, it's obvious here because we're assigning it a string on the very same line. But what you can do in VS Code is hit the keyboard sequence, which I'm doing right now. On Mac, it's Command K, Command I. On Windows, it would be Control K, Control I. So if I do that, Command K, Command I, then you can see it's telling me here, this variable is of type string. So that's type inferencing, where you don't explicitly physically include your type postfix syntax in your code. And what that really means then is that you really don't have to do as much physical typing in your source code. The compiler will infer the correct type for you. Some cases you may need to be, you will need to be explicit, uh, but in many cases you can leave it out. Now, as a beginner TypeScript programmer, you will probably use explicit typing. Uh, but as you get more experience, and by more experience, I'm talking about, years or maybe months rather than days or weeks, you'll find that you will realize I don't need to be explicit about the type for a variable. The compiler will infer the correct type for me. So if we scroll down to where we've got lots of type inferencing going on. Now, in the example I've just shown you, it's trivial, but the compiler is kind of can be quite clever as well. So what I mean by that is, okay, so here's a simple example of type inferencing. I have no type declared for this variable, but it'll obviously infer it as a string. Similarly, Boom, boom. See now. Like if you, okay, it's again, it's a fairly trivial example, but this is a string and we're accessing the linked property of that string and we're assigning that to a variable. Clearly, this variable is of type number, but I'm not stating that using the postfix syntax, but the compiler will infer it. And I can prove that by going Command K, Command I, and it has worked out. Where is it telling me that? So now just leave it with me for a second. Let's do that again. Command KI. You can see here it's inferring that it's of type number, which is correct. And if we take it a little bit further, so here we've got a friends array. Do I have my nums? Where's my nums? Okay, that must have been earlier on. Let's just keep going. I've got here a friends array, which is an array of person objects, and I defined person earlier on in my in this script. So that's fine. So there's no type inferencing going on there. But if we look at this line of code here, I'm calling filter on an array. Now we know that the filter method returns an array where the elements in that array are of the same type as the elements in the source array. Here's my output array from filter. I'm not being explicit about its type, but again, if I go Command K, Command I, it is correctly inferring that it's of type person array. And so that's type inferencing, a slightly more elaborate or intelligent example of it going on by the compiler. Equally inside here, I'm passing the filter method a callback. So here's my callback function. It takes one argument. I'm not telling it what type this argument is. I could have went in here. I could have went colon person. Okay, and the compiler would be happy. But I could actually let it infer the type. So if I get rid of that, and again, check with the did I delete something silly? I did actually. Let me just undo that. Okay, so if I go Command K, Command I on this, it has inferred person is of type, or sorry, friend is of type person. So this type inferencing is much more powerful than just simple examples like I showed at the beginning. And the main benefit of type inferencing is, as I'm saying in the bottom of the screen here, it just makes the developer more productive simply because they do not have to physically type as much syntax as they would have if there were not type inferencing. Functions, declaring functions from a TypeScript point of view, you have to declare the signature, the types associated with the signature. And we saw this in a few slides back. So simple example going on here. And this is where you're stating the return type, which can also be inferred in many cases. So if we look at this example here, I'm not stating what am I doing? I'm passing in an array of numbers. The function is mapping over the array, and it's just doing a simple arithmetic operation. So that would mean that this thing here is also an array of numbers based on what's being returned here. And so what we're returning is an array of numbers, but I'm not being explicit about the return type here. Yet when I do Command K, Command I on this function, it's telling me that the return type is an array of numbers. Do I have that in the source code? We go into, move on to the functions. Uh, don't have that exact example, but if you just take this example here, where I'm not stating the return type, but yet if I mouse over the function and go Command K, Command I, the way you can see there that it's saying the return type is number. So it has worked that out. In terms of arrow functions, this is how you specify the signature from a typing point of view. Okay, so I've got this function called add strings. It's an arrow function because we can see the arrow symbol here. And what I've highlighted here is the signature of the function. Yeah, and okay, all I'm just kind of giving you another example here, but I've this rotate function. The idea is that I pass this rotate function a string, and I pass it what I'm calling an axis. And the idea is that the rotate function looks for the axis within that string, and it rotates the string around that axis. However, the axis could be specified as a string or as a regular expression. And if we just ignore the body of the code for a moment, so here I'm passing it this string here. I'm calling my function. Where am I calling it? Calling the function rotate with source, which is this string here. And I'm actually passing it a regular expression. So I'm saying look for two consecutive digits in the string, the first occurrence of two consecutive digits in the string, and rotate it around that. And you can see here I've got 1, 2 as two consecutive digits. So it should do that. And you can prove by looking at the console log that it actually works. So I'm passing it a regular expression in this case as the second argument. Whereas here I'm calling the rotate function with source, but I'm actually passing it a string in this case. And the string is the letter, the at symbol, sorry. So where's my string? Here's my string, and there's the at symbol. So it's rotating around the at symbol. The string can be of any length. It doesn't have to be of length 1. The point of the example, well, there isn't, like it's suppose it's the fact that your arguments can be, your parameters can be anything, right? In this case, I'm saying the second parameter is something or something else, right? Now, I could have used type aliases there instead. I could have went something like this, type axis equals take this out. And then in here, say that axis is now of type axis. I'm missing something. I'm missing the closing brace, I'd say. There. I didn't like that. Yeah, and that would all work. That's probably slightly better written, but it's marginal. Now, there isn't really any type inferencing going on there, but or is there? It's probably there is some type inferencing going on inside here. Okay, like I'm not declaring the type of that, but the match function returns a type. Not sure what it returns actually. Let's try it. Command K, Command I. AI. It's of type string. Yeah, okay. And so there's various type inputs going on inside here actually. I haven't declared the type for that variable either, and so on. You can look at it yourselves later on. But as I said, type inferencing is something that you probably uh, will get better at as you work your way through. Higher order functions, you might remember from last semester in web app dev, there was a lot of higher order functions going on. A higher order function is a function that takes a function as a parameter. And so the question is, how do you specify the type for a function parameter? Here's an example, and I'll leave it at let's just look at the example. Again, it's a kind of made up example. So we've got a function called print to console, and it takes two arguments. It takes a string, and the second argument is meant to be a function. As you know, generically, when you pass a function to a function, generically we refer to the function parameter as a callback. So I'm just using that name here. So it's kind of meaningless, but the point I really want to focus in on is this here. You've got to specify the signature of the callback that you're passing to your main function. And this is the syntax that we use. It's kind of like arrow function syntax, but what we're declaring here is a type. So we're saying the function has to be a function that takes one parameter of type string, and the function has to return a string, in this case anyway. Also, by the way, if you've got a function that doesn't have an explicit return statement, then the return type is the void type. That's just by the way, because you can see this function here doesn't have a return type. So we are stating here that anytime you invoke this function, the callback that you pass to it, that function has to honor this signature. It has to take one parameter of type string and return a string value. And okay, let's flip over to VS Code. That's what's going on here. That's what we saw on the screen or on the slides. And here I'm invoking it. And I'm invoking it. So this is the second parameter. Yeah. And if we look at that, which I've highlighted, that's an actual function But from a signature point of view, it's honoring what we wanted, which is that the first parameter is of type string. And based on the return statement, because I'm just doing an uppercase on the string, I am also returning a string. So the compiler is happy. But let's supposing I did this instead, right? Let's supposing I went s.length. Now, s.length, that expression is going to be a number. So this function that I've passed in, this callback function that I've passed in, takes a string as an argument, but returns a number. And you can see the compiler is complaining. Sorry, let's get rid of that. The compiler is complaining here. And if we look at the explanations, sometimes the explanations are useful, sometimes they're not. But essentially what it's saying here is that in your print to console function, you said that the second argument has to be a function that takes a string and returns a string. Whereas down here, I'm invoking my function, but the callback that I'm passing to it takes a string and returns a number. And that's what the compilation error is telling us down here. Okay, so we have to correct that. And okay, the example we had was that. So now the compilation is clean. So the compiler is clever, like it will drill down any number of levels to ensure that you are respecting, in this case, a function's set of parameters. Now we've got a more elaborate example going on here. And I think just maybe from a time point of view, I should pause it now. We did lose some time, but maybe if I just pause it here and pick up the story the next day. Where are we in time? I'll just try and cover it if that's okay. Can we do it? Let's see, is there too much? Maybe not. Maybe I'll just freeze it here, which means we haven't made a whole lot of progress. If I go back to the website, where's my website? Okay, there is a lab that I'd like you to start working on. If I go into the lab now, now based on what we've done, you will be able to do this section, this section. You should have a go at this section as well. See how far you can get. And then the remaining sections of the lab, we will be able to complete after next week's lecture, assuming that Zoom doesn't give up on me again next week. But for now, you can start working through this lab, I think, yourselves. You will have to submit this lab when it's finished, but that's certainly probably going to be at least the end of next week before you'll be able to achieve that. But you can get started on it anyway. Okay, I'm going to stop there. I didn't give you any opportunity to ask questions, which is kind of typical of me, but I'll pause anyway for a moment in case there are any questions, either specific to the code that I've been showing you or more generally. No. Okay, I will touch base with you. Now, there are obviously the labs tomorrow won't run. In general, the labs for this module, they are scheduled in some IT rooms. It's optional really as to whether you actually want to turn up in the rooms or not. You can work on the labs remotely, and I will accept questions on the labs over Slack. But I will turn up in person in the allocated rooms on the Fridays from here on in the main anyway. But it's I won't be too concerned if some people don't turn up physically in the labs. As long as you work your way through the labs, I'm happy with that. Okay, I'll leave it at that for today, and I'll touch base with you again next week. Thanks. Bye bye.